In this lecture, we'll begin exploring PLC counters. Program counters perform the same job as mechanical counters. They record how many times an event occurs. Every time the actuating lever or sensor changes state, the counter adds one count. Unlike timers, counters depend on external events, not an internal clock. Most PLCs provide three main types: count up, count down, and combined up-down counters. Counters are often used to track production items moving past a sensor. PLC counter instructions are similar to timers, but instead of measuring time, they count external events. This diagram shows a coil-formatted up counter labeled CDU. Each time the input changes from off to on, a false to true transition, the counter adds one count. PR is the preset value, the target number. AC is the accumulated value, the number of counts recorded so far. When both are equal, the counter's done bit turns on, signaling the program to take action. The counter reset instruction must always be used with a counter. In this diagram of a generic counter, we see a count rung and a reset rung. Notice, the reset coil uses the same address as the counter it is linked to. This allows the PLC to know exactly which counter you want to clear. When the reset rung becomes true, meaning the input condition is activated, the accumulated count immediately resets back to 0. Think of it like pressing the reset button on a mechanical counter. It instantly clears the total, preparing the system for a new counting cycle. Notice in the diagram that both rungs, the count rung and the reset rung, share the same counter address, labeled XXX. The top rung counts upward whenever the input goes true, while the bottom rung resets that same counter when its condition is met. Up counters are always reset to 0. This ensures that the next set of input pulses begins a brand new count from a starting point. In an actual program, this reset could be tied to a push button, a sensor, or even an automatic control signal, depending on your process needs. All PLC counters operate on what's called the leading edge of the input signal. This means the counter reacts at the exact moment an input changes from off to on, also known as an off-to-on transition. Each time this transition occurs, the counter increases its accumulated value by 1. You can think of this as the PLC taking a snapshot every time a sensor detects a new event. In this example, a photoelectric sensor on a conveyor sends a pulse each time a part passes by. The input module receives these pulses through the count line and sends them to the counter block. Inside the counter, three main values are stored. The type of counter being used, the preset value, which defines the target count, and the accumulated value, which records how many events have occurred so far. Once the accumulated value equals the preset value, the counter's done bit turns on, activating an output line. The reset line works just like before. When the reset condition becomes true, the accumulated value clears back to 0, allowing the system to begin a new counting cycle. PLC counters can be programmed to count up or down to a preset value. In the top diagram, the up counter increases its accumulated value by 1 each time the input rung turns on. For example, when a limit switch closes. The PLC keeps adding 1 for every input pulse until the accumulated count equals the preset value. When that happens, the done bit turns on, triggering an output or another action. The down counter works the opposite way. Each time the input rung is energized, the accumulated value decreases by 1. Down counters are useful for tracking remaining items, like parts being removed or inventory used. In both cases, the counter reacts only to signal transitions, not how long the signal stays on, ensuring each event is counted just once. Now, let's take a closer look at the up counter, the most common type used in industrial applications. The up counter is designed to track how many times an event occurs, such as parts moving down a conveyor, machine cycles, or button presses. Each time the input signal makes an off-to-on transition, the counter adds 1 to its accumulated value. When the accumulated value equals the preset value, the counter's done bit turns on, signaling that the required count has been reached. In the next slides, we'll look at an example that uses an up counter to control two pilot lights. A green light when counting is in progress, and a red light when the target count is reached. Let's see how that works. Let's look at how an up counter operates in a real PLC program. In this example, the system is designed to turn on a red pilot light and turn off a green pilot light after a certain number of button presses. The push button labeled PB1 provides the counting signal. Each time is pressed, the counter increases its accumulated value by 1. The preset value for this example is 7. That means when the counter reaches 7 pulses, the done bit turns on. As long as the accumulated count is less than 7, the green pilot light remains on, showing that the system is still in operation. But once the 7th pulse is received, the counter's done bit, labeled DN, becomes true. When this happens, the red pilot light turns on, and the green light turns off. This gives the operator a clear visual signal that the count limit has been reached. Finally, there's a second push button labeled PB2, which is used to reset the counter. When PB2 is pressed, the accumulated value returns to 0, and the system is ready to start counting again. This simple example demonstrates the essential behavior of all up counters. They respond to external pulses, track each event, and take action once a preset number is reached. Let's watch a Logix Pro simulation of the up counter in action. We start by pressing push button PB1 at input I1/0. Watch the first rung as the counter begins counting toward its preset value of 7. The accumulated value increases by 1 each time the push button is pressed. 1 count for every off to on transition. Next, press push button PB2 at I1/1 to reset the accumulated count to 0. In the Allen-Bradley SLC 500, all counter data is stored in file number 5. Each counter has a unique address. For example, C5:3 means counter number 3, located in file 5. Every counter file contains 3 main words. Word 0 stores the status bits. Word 1 holds the preset value, and word 2 holds the accumulated value. The status bits include indicators such as count up, count down, done, overflow, and underflow. These bits provide feedback about the counter's current condition. In the counter table, you can view each counter, C5:0, C5:1, and so on, along with its individual bit values, preset, and accumulated counts. The count up enabled bit, labeled CU, turns on whenever the up counter instruction is true. In other words, each time the input rung goes from off to on, the CU bit energizes. The countdown bit, labeled CD, works the same way for down counters. It turns on each time the down counter rung is true. The done bit, labeled DN, becomes true when the accumulated value is equal to or greater than the preset value. For example, if the preset is 7, the DN bit activates on the 7th count, signaling that the target has been reached. When the DN bit turns on, it can be used to trigger other actions in the program, such as lighting an indicator or starting a new sequence. The overflow bit, labeled OV, turns on when the counter exceeds its maximum positive value of plus 32,767. When this happens, the counter wraps around to negative 32,768 and continues counting upward from there. The underflow bit, labeled UN, does the opposite. It turns on when the counter goes below negative 32,768, wrapping around to the positive limit and continuing to count down. Finally, the update accumulator bit, labeled UA, is used when the PLC is connected to an external high-speed counter, ensuring accurate synchronization between hardware pulses and software counts. The preset value, labeled PRE, defines the target number of counts required before the done bit turns on. For example, a preset of 7 means the done bit activates on the 7th pulse. The accumulated value, labeled ACC, shows the current number of counts the PLC has received. Each time the rung goes from false to true, the accumulated value increases by 1. Together, the preset and accumulated values give the programmer a clear indication of the counter's progress and help verify that each count is being recorded correctly in the system. Now that we've looked at how the counter file stores its data, let's see how the upcounter instruction appears inside the ladder logic. In this example, we're using counter C5:0 with a preset value of 10 and an accumulated value starting at 0. Each time the input rung goes from false to true, the counter increments the accumulated value by 1. When the accumulated value reaches the preset of 10, the done bit, labeled DN, turns on, indicating the count is complete. Below the counter block, you can see several status bits displayed individually. The CU bit is the counter enable bit. It's true whenever the rung containing the counter is true. The DN bit is the counter's done indicator, turning on once the preset value is reached. The OV bit is the overflow status bit, which turns on if the counter exceeds its maximum limit. Finally, the reset instruction, labeled RES, is tied to the same counter address, C5:0. When the reset rung is energized, it clears the accumulated value back to 0, allowing the counter to start a new counting cycle. We close out this lecture by looking at a can counting system used in an automated packaging line. A proximity switch, labeled PROXSW, is mounted beside the conveyor belt. Each time a can passes in front of the sensor, it detects the metal surface and sends a short on pulse to the PLC input module. This pulse is what triggers the counter to increment. Counter C5:2 counts the total number of cans coming off the assembly line for final packaging. Each package must contain exactly 10 parts. As each can passes the proximity switch, the input pulse increments both counters. Counter C5:1 keeps track of the cans in the current package. When 10 cans are detected, C5:1 reaches its preset value and sets bit B3:0/1. This bit activates the box closing sequence, signaling the system to seal and move that package off the line. Meanwhile, C5:2 continues to count every can for total production tracking. It doesn't reset after each box. It serves as the total can counter for the entire shift or day. Once a box is closed, C5:3 increments by 1 to record a completed package. This counter tracks how many boxes have been filled in total, with a maximum daily count of 300 packages. A reset push button is included to restart both the part and package counters at the start of each day or shift. Pressing this button clears C5:1, C5:2, and C5:3, resetting all accumulated values back to 0. In the next lecture, we'll explore how to use one-shot instructions to control when a counter increments, ensuring that each event is counted only once, even when input signals remain active.